Today we have Marcus Taylor. He's been working at Southern Heat Exchanger on a very unique project that sort of matches some design software with 3D software and is helping to automate the actual 2D drawing process, which is sometimes one of the more complicated phases of using a 3D model, is changing it from the 3D to a usable 2D drawing for the shop floor. So I'm going to let Marcus Taylor take it away.
Thank you, Jody. Thank you, Alan, for your presentation and for having me, and everyone else here at APC. Thank you. So this is Marcus talking, and I guess I'll go to the next slide. If we can here. There we go. I'm a rising senior at the University of Alabama, pursuing my degree in mechanical engineering and a minor in computer science. I've been with APC since the end of February now, I believe. I'm working with Southern Heat Exchanger here in Tuscaloosa. And this is a little bit of information about Southern Heat. So they do exactly what their name sounds like. They produce heat exchangers, which that graphic down there at the bottom is a little 3D model of one of their units. But you can see some of the certifications and numbers about output the company had last year. So my project I've been working on in conjunction with Jody has been the implementation of Compress, which is a software I will get into shortly, as well as the 2D drawing side that Jody mentioned. But some of our goals with this project were to improve their design process, provide solid models to their customers, which I'll get into exactly what that means in a little while, but that is something that they currently do not offer, which a lot of their customers have requested. And based on their design methods right now, is not something they were capable of providing. So we hope that this project will provide that solution for them. That third point there, link information, is very important to the design process for the company right now, because they are doing a lot of manual data entry, which causes some errors here and there. You know, people aren't perfect, so they can't always accurately reproduce that information. So our program hopefully will take care of some of that manual data entry. And then the third, or the final thing there, is to catch some of those design errors, which will go ahead and get to this design process here. So you can see this process is busy, and if it looks busy to you, that's because it is. So our goal with the first half of this project was mainly to shore up this left half and streamline this design and drafting process and try to shorten that as much as we can. And the second part, which is mainly where I am operating, is here in this revision cycle, as I call it. And to do that, to improve that, we hope to reduce the number of cycles between the drafting and engineering department and hopefully decrease those lead times for the company. So Compress is a productivity tool, and it's software produced by a company called Codeware that significantly decreases the amount of time it takes to actually design the exchangers that the company produces. And this part was mainly done by Jody Beck. When he was still with the company, he did the research and found this software and purchased the licensing and whatnot. And he has gotten me caught up to speed with it. And it is very useful. And I actually have a demo here. This is a screen capture on my computer that I took at work, going through and giving an example of what the software is capable of. So I'll just run through this here. You can see all the information that comes with using the software. And you can imagine doing this all by hand or through another method, but this will certainly decrease the amount of time it takes for the company to actually produce those exchangers and produce a solid model as well. Also, if y'all have any questions, feel free to interject. I've saved time at the end for questioning, but you know, if you have a burning question, feel free to go ahead and stop me at any point. So that's actually, that pop-up there was it catching a design error, so I went ahead and said, yeah, go ahead and use the recommended setting. And so you can see we now have a solid model, and I wouldn't recommend using this particular model because I just kind of arbitrarily went through the software, but you can see in the hands of good engineers, it can dramatically decrease the amount of time it takes for them to produce that solid model. So compress is good at a few things. You can see the increase in design efficiency there. We get those solid models out of it, and it catches some of those design errors that plague the design process currently. So you can see this is a little update to that design process, and if you notice the left portion there before that revision cycle has been shortened to a few steps. And what's significant in those steps is that there's no longer this manual data entry that causes a lot of those design errors. So moving on from there, our next step is mainly my portion of this project, which is the automation of the 2D drawings. And this hopefully is to decrease those revisions in that cycle. So we're going to do this through Inventors, which is the CAD software that the company has chosen to use, through its programmable interface, and we're going to do that through Microsoft's Visual Basics, which I'll get to in a minute. And so our goal is to automate these drawings as much as we can, and a big, exciting feature of these drawings in Inventor for the company is that these drawings are actually linked to the properties of that solid model. So if the engineers make any revisions to the solid model, whether it be dimensioning or materials and whatnot, that is all automatically reflected and updated in the drawings themselves. So a little bit about Visual Basic for those who are unfamiliar. It's actually a programming language written by Microsoft, and it showed up in the early 90s. Its main use is in Excel, automating features and functionalities within different Excel documents and whatnot, but there's a whole host of applications that it is now available for. And so you can see there I've listed a couple of them. It's expanded outside of the Microsoft realm of software into some of these CAD softwares that people are using now, and even Skype. I'm not sure exactly what you can do with it in Skype, but in my research I did find that you could use it in Skype, which I found interesting. So the main uses for VBA, it can do almost everything you can do in a piece of applicable software by hand. So calculations, formatting, all of these types of things can be automated as long as you have a programmable task list, so something that you can predict the outcomes for. So I'll run through, this is a screen capture of Southern's drawing format, and these are the drawings that we have been working on reproducing automatically. So you can imagine going through as a drafter there for the company now. These drawings take quite a bit of time to actually produce. So I've been with the company for about 2 months now, and I just started my summer internship. And so I'll kind of, in the next couple of slides, run through the progression of where this project started. So this was in my first couple of weeks of my time with the company, and this is me demonstrating some of the code that we're working with. Yeah, this actual video won't be overly impressive to anyone, but for me it was very exciting because I'd worked on this for several days and could not find a solution to it. But here at the end, when I actually run this bit, you can see it opened a drawing and it actually placed a view, and it did happen to crash on me at that point, which I had to find a solution to afterwards. But that was exciting at the time because I knew the capability was there to actually place views of a model. So from there, we got into placing some of the information on that first page that was shown in that run through of the drawings. So in this video, I will run through and open a format eventually. And so from there, I will run a program I had written to actually populate some of the information on this page based on a model I also have open, which that was also an exciting breakthrough, because from there we knew that we could populate this type of information on pages based on a model we have open. So this program is still in its infancy. The majority of my summer will be spent actually doing the main build, as I call it, the programming of this project. But this is a kind of a video of where we currently stand with the program. And so we've come a long way from that first, placing of a drawing view and then the program crashing on me, as you'll see from this video. So you can see it was very quick, and in that time we created 4 new pages, formatted those pages, placed some drawing views there. This third page, the third page is almost complete despite some of the data information and whatnot. And then there's the 4th page, which is incomplete. But you can see the capability of this program to populate hopefully the whole drawing, but if not, a very large portion of this drawing is there. So what's left for me to do over the summer is there's a few more things I'm looking on controlling with that programmable interface, including dynamic dimensioning and controlling size and whatnot of like certain figures, data and figures and whatnot. From there, we're actually going to get the feedback from the other engineers, the draftsmen, and anyone else on the floor about any formatting issues. We're going to standardize that formatting and make it a little easier for everyone who's using the drawings to be able to use. And then from there, we'll actually start coding and designing the tree of the program and adding the logic that it needs to be able to decide what type of exchanger it's looking at, what type of drawing it needs, what type of views, what information to be placed and whatnot. And then from there, I'm actually going to use this, what's called a macro, which is just a program within Inventor, to hopefully create a full-fledged add-in program for Inventor. And that's primarily for user functionality. It's easier to use when it's just a button there in the toolbar to use within that software. And then from there, we'll introduce it to engineering and drafting, get their feedback, and do some debugging based on their input. That hope will probably come after this summer. We believe it'll take at least the next 3 months or so to have the program working at a high enough level to introduce. So these are some figures that were calculated actually before I was put on with this project. This was done by Jody when he was still with the company. So you can see the main time savings there is within the engineering department. And this was done before we even got into the complexity that we're hoping to achieve. So we're hoping that time savings could actually increase from this point on, which is exciting. And so these are some of the dollar figures that go with that information there. So once again, we're hoping that we could actually, produce even more value than this in the future, as long as we finish the program how we believe it can operate. So at this time, feel free to take any questions and concerns that you all may have.
How did you get connected to this? What interested you in this project? Were you already a part of the APC program, and then this opportunity came up, or did this opportunity come up and that's what convinced you to become active with APC?
Yeah. So one day I sat down on my computer to do my homework, and the first thing I do to procrastinate is always check my email. And there was an email sent out by one of our professors that had been in contact with Jan, and there was a description of the project, and I was reading through it, and I was like, wow, this is, it's almost like they were writing it to me, because they were looking for somebody that had experience with Inventor. And at my last summer internship, I had worked with that CAD software for 6 to 8 hours a day for months, and I had some very high-level training there from some of the people I was working with. So I was very familiar with the software they were trying to implement. And another thing they were looking for was somebody with, ideally a minor in computer science or with the background. And I had started my minor a little over a year ago now. And so when I read that, I was like, wow, it seems like to be a very good fit. So I sent in, a resume, and it went from there.
That's great. That's great.
One thing, this is Jody speaking. One thing I'd love to add is what Marcus has accomplished here in the last 2 months is something. When I was at Southern Heat, we had training from a a professional about how to use Inventor. And we came to a point where we actually had a roadblock where our trainer didn't even know how to accomplish what we were trying to do. And specifically what I'm talking about is being able to get all that information that Marcus is populating. You know, the drawings aren't complete as we sit right now, but the how to do it is pretty close to complete, which is pretty amazing for the first 2 months. And he got through a roadblock that our trainer had no idea how to accomplish. And by doing that, he's removed that. All that's mostly left to do is the you know, actual just monotonous work of placing the information on the drawing. He's already been able to dig down and grab information that was not previously thought possible. So his addition to this was absolutely amazing.